In this example, we will let z equal -2 plus 2i squared of 3. We are going to find the two complex square roots of z, represent our answer in both complex polar form RCAS of theta, and in rectangular form a plus bi, simplifying any trigonometric expressions. So, if we do want to find the complex square roots, the first thing we're going to do is to take z and change that into complex polar form. Let's quickly determine that. The modulus of z here, we can use the Pythagorean theorem for that. That would be -2 squared plus 2 square root of 3 squared, all under a square root. -2 squared is 4, 2 square root of 3 is 12, and the square root of those two values summed together would simply equal 4. For the argument of z, though, when we use arctangent for that purpose, do keep in mind where your complex number currently is. -2 plus 2i root 3 has a negative real and a positive imaginary, which puts us up here in quadrant 2. If I just evaluate this as arctangent of the imaginary piece divided by the real piece, 2 square root of 3 divided by -2, that would not currently give me the correct answer, as that would actually define an angle measure between -pi halves and 0 in quadrant 4. But if I add pi to that solution, then I would get an angle measure in quadrant 2 instead. Arctangent of 2 square root of 3 divided by -2, if you simplify the inside of square root of 3 over -1, you will find that this gives you -pi/3. And if we then add pi to that, we get the correct argument in quadrant 2 of 2pi/3. Meaning that I can write z as 4 CIS of 2pi/3. Now we're going to need that in order to come up with the two complex square roots of z. If we apply the root formula for this, for finding the complex numbers, so z to the 1/2 power, that would be the square root. Since we're looking for a square root, there should be two solutions for this. I'll represent those as w sub 0 and w sub 1. The first square root is where we're going to take the modulus and take that to the power as well of 1/2. And then for the angle measure, we're going to take our angle measure and divide that by 2, or multiply by 1/2. And we're also going to have plus 2 pi, also multiplied by 1/2. And we're going to plug in 0. Note that the value that we plug in here is technically going to be the same as the subscript for w. This is why we use this notation. We'll be plugging in 0 here based on that subscript. My second solution is going to look exactly the same. 4 to the 1/2 power, CIS of 2pi/3 divided by 2, plus 2pi/2, and in this case we're going to plug in the subscript of 1. That is how we will generate the two different solutions. If I simplify those, 4 to the 1/2 power we have is 2. And then 2pi/3 divided by 2 is just pi/3. Plus this term here would just be 0, so that's it for the first solution. For the second solution, we're going to get 2 CIS of, again, we're going to get pi/3. But then we're going to have plus 2pi/2 times 1, or just plus pi. Meaning that this is 2 CIS of pi/3 plus pi is 4pi/3. So we have our two answers currently in complex polar form. I can now expand those out in order to get them into rectangular form. 2 CIS of pi over 3. We should not need a calculator for that. That is going to be 2 times cosine of pi over 3 first. Cosine of pi over 3 is 1/2. Plus I times 2 times sine of pi over 3. And sine of pi over 3 is square root of 3 over 2. So that would be 2 times 1/2 is just 1. 2 times square root of 3 over 2 is just the square root of 3. So I'll say 1 plus I times the square root of 3. Or 1 plus square root of 3 times I if you would prefer. The second solution, 2 CIS of 4 pi over 3. This is going to be very similar. However, instead of positive 1/2 and positive square root of 3 over 2, we will have negative 1/2 and negative square root of 3 over 2. 2 times negative 1/2 will give me negative 1. 2 times negative square root of 3 over 2 will give me negative square root of 3. We have negative 1 minus I square root of 3 as my second solution. Those would be the two complex square roots of z, both in polar form and rectangular form. Keep in mind that if you would ever like to check your answer for these, simply take either solution that you have and take those to the second power using the power rule. If you take them to the second power and you can generate the original answer of negative 2 plus 2i square root of 3, then that means that your roots here are correct.